Welcome to Energy Innovations, a regular video series that explores the latest innovations in technology, digital, regulations, products, services, finance, and business models that are impacting the energy sector. Energy Innovations interviews entrepreneurs, energy companies, capital markets, and regulators to understand how the energy industry is changing.
Welcome back to Energy Innovations. And today I want to dig into this framing of a specific technology area called digital twin. And in this case, with quite specific reference to the human aspect of digital twin technologies. Most industrial examples of digital twin tend to concentrate on a physical asset. But in heavy industry, there's a lot of people around that keep these assets running and well maintained. And there is a benefit of having a better digital understanding of that workforce and what their activities are. And to do that, I'm joined today by Matt Kleiman, who is the CEO and co-founder of a company called Cumulus, based in beautiful Boston, Massachusetts. Matt, welcome to Energy Innovations.
Hi, Jeffrey. Thank you for having me. It's great to be here.
Now, the main problem Matt and I have when we get together is that we laugh too much. And so the trick for this show is how do we maintain focus on the content and not get too...
We'll try to keep it very serious.
Keep it very serious, exactly. But so let's begin. As I mentioned in my preamble, there's lots of conversation about digital twin, and this video series has actually explored this topic a little bit in the industrial asset sense, but we've not ever really focused on this sort of human dimension of it. I wonder if you might help me unpack that a bit and explain what digital twin means in a more human-oriented context.
Sure, and Jeffrey, you did a fantastic job setting it up. The most digital twins today, when people think about a twin of either a facility or a piece of equipment, it's a 3D computer representation of what is happening in that facility or equipment or piece of equipment, like an engine for GE or a construction project. But as you mentioned, digital twin technology today is really focusing on physical presence. So was a piece of a building installed? Was it installed according to plan? Is an engine functioning properly, or is there a problem with the vibration or something else? They don't tell you anything about the people. So who actually installed the building? How long did it take them to do it? How well was that work done? And so it's really missing, the digital twin technology is missing half the story of the reason why projects are either delayed or mistakes happen or rework has to be done or there's accidents, which is very often an issue with either managing humans or human error. And so Cumulus, we use IoT and detailed workflows to create what we call a digital twin of the workforce, which gives you that detailed information about the workers and what they're doing, and how long it took them to do the work and how well they did the work, the same type of information that you'd want to get from that turbine or from the digital twin of a building.
So what works in a digital twin of a building is that we festoon them with sensors, we connect the sensors to the internet, we collect all of this data, and we feed it into a cloud computing engine, which interprets the data and then gives you, okay, here's how your building or asset is running. Translate that now to the human context. Are we visualizing workers with lots of sensors on their, say, hard hats or vests or something?
So you could. That's not what Cumulus does. What we do is we use sensors either on the tools that the workers are using themselves or equipment like pressure gauges, temperature gauges, things like that, all things that we could read into our system and understand what is happening. What's that interface point between the worker and the physical object? We're not looking at, putting the equivalent of a Fitbit on a worker and understanding biometrics. There's some really cool companies doing that. We're looking at that physical human interface. Where is the touch point and understanding what is happening at that project site based on that touch point.
Now, can you give me an example using, say, a typical piece of equipment like a torque wrench? Yeah, I'm
Sure.
visualizing, yes, worker at a field site, and they're working on piping. They're adjusting a flange. They're tightening the bolts. They're using a torque wrench. And how does Cumulus provide the data associated with that human action? Just using my torque wrench as an example.
Sure, that's a great example. So for torque and bolts in particular, we work with a number of companies like Snap-on and High Torque that make digital versions of their equipment that workers use. And our software sits on the mobile device the worker's using, and we connect with that equipment via Bluetooth, just like you connect your mobile device to a headset or your car. And we now have two-way communication with that equipment. So we're getting data from the tools itself. So as the worker is tightening those bolts on a flange, for example, our system knows what is that torque value supposed to be. We read what torque value is actually achieved. And then if there's a problem, if it was out of spec for some reason, we'll send an alert to somebody, but we'll also keep that record, that digital record of who the worker was, what they did, how long it took them to do it, when it happens, so that if there is an issue later, you have that almost like an electronic medical record of that work activity, but also a real-time view for managers into what is happening on their job site. So an example, we recently, a customer of ours building a large plant in Pennsylvania, there were 120,000 bolted connections that had to be done over about an 18-month period.
120,000.
120,000 bolted connections as part of this project. Now, they had their own traditional digital twin software. They worked with a drone company to do site surveys, and we were able to integrate with an API into that digital twin and their aerial site surveys, and then show all of the workers that were doing work on the site in real time, so that it added a whole new dimension to what they're doing. Not only can they see where am I according to my project plan, but they can see all the dozens or hundreds of work teams that were out in the field with real-time status of what was happening in the field by those workers.
Yeah, I suspect if you could capture that view, you could see visually in the moment lots of standing around time, lots of queuing and waiting, where and you could start to visualize in quite visceral ways. Here's bottlenecks in my process, my transportation, everything. I'm guessing is probably the value.
Absolutely, the whole step of work is it's very common in these projects for work has to wait for a more senior person to come around to either authorize the work to happen, so you've prepared the site properly, or the workers aren't allowed to leave the site until someone comes to sign off and go on to their next work order or work package. What our system surfaces, just as you said, is you can see visually and with the data, wait a second, there's in this particular unit of the plant, there are a lot of people waiting for the QC inspector to come around and sign off on the work. Why are they waiting so much? Why is that happening there and not in these other parts of the plant? Something's going on. Let's work to clear that bottleneck. Whereas using traditional systems, which is Excel spreadsheets or pen and paper, that might not be surfaced for days or even weeks after the fact.
Yeah, and by that point, it's way too late. It's kind of like saying, well, I'll try and fix my aircraft in flight only after it's landed. Well, if you can deal with it in flight, you probably should.
You should, because then you fixed it as it's come up. You're not waiting for someone to discover an issue long after it's done.
Exactly. Now back to the 120,000 bolts that had to be torque tightened on this particular plant. I'm guessing that if you're an employee, and your job is to carry out a certain task on site, say torquing bolts, you don't want to over torque because that causes problems. So there's probably a tendency here to under torque or hopefully get as close to the torque target as possible. Can you just explain a little bit of the human dynamic, the behavior that happens at a site that is what gives rise to this ambition by industry to connect the human and their tools to the actual work on site being done?
Sure. So with torquing, you see two things that commonly happen. One, people forget to tighten certain bolts or flanges at site. That happens all the time. And because it's visually hard to tell whether a particular bolt, unless it's extreme, it's hard to tell whether a bolted joint has been tightened or not. So if you have workers that for one reason or another, intentionally, unintentionally skipped a part of the plant, that is often overlooked during inspections after the fact until they start the plant up, and then there are major leaks. The other thing that happens is using traditional tools. As you said, they just over tighten the bolts. And again, you can't visually tell a bolt is over tightened once that has happened. And what happens there is, you can see my hands, I know it's hard on Zoom, but you basically compress the two sides of a flange together, and that's how you break the gasket, and that's how you get a leak. So again, what our system does, one, it will not, our customers are looking at our system to register, yes, all of this work has been completed, so you're not going to forget to do a section, because our system will show very clearly, nope, this section has not been completed yet. Don't start up the plant until you're done. And then on the other side, it will provide alerts that, hey, there were some over tightened bolts here, and that comes out in real time. Someone needs to go do something about that.
Yeah, it adds value in a couple of ways: avoiding rework, obviously, mitigating against unsafe conditions and dangerous conditions, offsetting the potential for leaks and other kinds of problems. Can you just unpack a little bit here? I mean, you mentioned some of the technologies that make this work, the smart tools. What exactly is a smart tool, and how is it different from tools in my toolbox? I got lots of tools. They're just metal, but what's the difference here?
So there's a bunch of, it varies a lot based on the type of tools you can imagine. So for instance, the torque wrench example, the torque wrench that our customers would use looks and works exactly like the torque wrench you would find in your home garage, except there's a pressure sensor on the head and a Bluetooth radio in the body that we can connect to, and we can and also an accelerometer on the tool that we could get a lot of information about what's happening on that piece of equipment. You have other tools we work with, pressure pumps, pneumatic and hydraulic pressure pumps. There, you have a few different things. Sometimes we can just replace the gauge on those pumps. We have a normal analog gauge with a dial. Could replace it with a gauge that has a digital gauge, has Bluetooth radio, it's intrinsically safe. And now we've turned that $25,000 dumb pump, so to speak, into a smart pump, because now we can communicate with it and we can get those pressure readings. We could do the same thing for hydrostatic pressure testing using similar technology. Instead of analog gauges and paper chart recorders, you have a digital gauge, and we're pulling that data off automatically in real time. So it really varies. Sometimes we can just retrofit what exists today. Sometimes the OEMs are actually putting the connectivity into the tools. You can go to the hardware store today and you can find a whole host of everyday power tools that have connectivity that you could use in your own home.
Now, these tools and devices, you mentioned there's a Bluetooth radio in them. What's their power supply? Or do they carry a little battery or something?
Yeah, typically batteries, and depending on the tool, sometimes it's a simple rechargeable battery. You could just, AA, AAA batteries, you swap it out. Others, especially ones that are intrinsically safe, have more advanced batteries and more packaging around those batteries to make them explosion proof. But they're also rechargeable and they last quite a long time.
Where does the data go that comes off of these devices? Is it, I'm imagining in an industrial enterprise with SAP or Maximo or something, driving its field maintenance and operations. Like, is this data flowing into that system, or is it going someplace else instead?
It very well could. So the path of data in our system, it goes from the tool to the mobile device, which is running our app. And we do it that way so that a worker could use our system even if they don't have any internet connectivity, which is very common out in the field to be, no Wi-Fi, no wireless connectivity. So it can work offline mode just as easily as online mode, but the data goes from the tool into the mobile app, either in real time if they have connectivity, or once they get to connectivity after a shift. It syncs with our cloud server, which sits on AWS, which goes into our dashboard where all the data is stored and visualized. And then we have APIs that allow our data to be shared with whatever engineering or maintenance management system our customers are using. And we have two-way communication. Either our system can be the source of truth, or we could use our customer system as a source of truth. And we just share data back and forth that way.
So it sounds like the adoption of this is pretty straightforward. The tool to the worker is going to be the same tool they've always used. The training they've used to learn how to use a torque wrench, not going to change. The training they use to read a gauge at a pump, that's not going to change. So the intervention here in adapting to this at that sort of frontline worker feels like it's pretty light. Is that accurate, or am I missing something?
It is. One, it's entirely self-contained, so you don't need to make any infrastructure changes to the facility to use a system. And that was so the background of the company is my co-founders and I, before we started Cumulus, we all worked for Shell. And this is where we first saw this problem that had to be solved. And we left Shell with Shell's blessing in a very friendly way. Shell's a great customer and they're an investor in Cumulus. But we left to solve this problem, which we lived as we were working in operations and maintenance. So we understood that there were a few things you had to do in order to get adoption. One, don't ask the customer to make any changes to their facility, because that involves a whole other level of change management that really hinders a lot of adoption. And two, we make it as easy as possible for the workers to use. So we don't change their workflow, their work process at all. Excuse me. They just use their regular tools that work just like non-digital tools would. And they use the same workflows. All the workflows in our system are customizable to match whatever the facility's workflows are. And they go about their business as they would, except now they don't have to fill out paper. They don't have to carry around specs and drawings, because those are all handled in our app. And they don't have to fill out any paperwork after the fact, because we're capturing all the reporting digitally.
Yeah, it actually, by the sounds of things, it actually takes a bit of work away, and work that, knowing most of the frontline workers that I know, it's a harsh environment. You're often under conditions which make writing stuff down painful, if not impossible. So if you can take that away, and capture it automatically, it would seem that the workers would, after they get over the big brother surveillance kind of problem, the sort of mental view, hey, you're watching me too closely. I assume they get to the place where they go, well, actually, this is quite convenient. I don't have to have this paperwork hassle I have to do at the end of the day.
They do. They end up, once they start using it, they don't want to go back to the old way in other job sites they're working at. It's one of the best ways we get new customers and new users is as workers and managers go from plant to plant and say, no, we don't want to have to go back to doing all this paperwork.
Yeah.
We want to just capture it automatically. And it's the annoyance factor that goes away when you use it, but also the record keeping. So we had a number, when COVID-19 first hit, for example, a lot of job sites just shut down very quickly, because everybody was just sent home until we figure out what to do. I'm talking March 2020. Well, what happened at a lot of sites is a lot of paperwork was lost because the workers dispersed. There was oftentimes deep cleaning at these sites that happened, and paperwork was lost, and there was a huge amount of rework that had to be done for sites that were using traditional pen and paper or Excel spreadsheet methods. Once the workers came back to the site, weeks or months later, for our customers, we started to hear stories where, for the systems where they were using Cumulus, they just came back and picked up right where they went right where they started, because everything was digital. And even if it was different workers, they just log on to the system. All right, I'm at this part of the plant. Where did the people leave off 3 weeks ago? I'm just going to start there, and nothing is lost. And that's not just Cumulus. That's an argument for digitalization generally, but it was a really striking example of how much time and effort can be lost because everything's on paper.
Yeah, yeah. It's just imagining the 120,000 bolts example. You have a shutdown and then come back 3 weeks later. Well, which bolts did we actually touch?
Where were we, right? Where were we on this job?
Right.
It would have been hundreds of thousands of hours wasted if they had to start redoing all that work.
Yeah, significant productivity gains. Which industries does this apply to besides heavy industry? I mean, I'm imagining this could factor into a whole variety of industries.
Yeah, so we view our market as any industry where that's mission critical in the sense that a failure of quality or a failure of schedule has a high cost. And that cost can be financial, it can be safety, it can be environmental. Usually it's all three. So we have customers today. Oil and gas is certainly our biggest market. Data center construction is becoming a very large market for us. We actually just recently won a startup competition at a data center world in Austin because they have the same problem, except instead of hydrocarbons, you have high voltage electricity. So data centers is a big one. Renewables, pharmaceuticals. We have a couple of customers who are manufacturers of pharmaceuticals in different parts of the world. And if they have a quality issue, there's obviously a problem. Aerospace is another one that we're looking very closely at, and a few others. But today, for Cumulus, energy, data centers, pharma are the big three.
And is there a regulatory thread to all of this, where a regulator is potentially asking, who, not only what pump is installed if you have a pump failure or a pipeline failure, but who actually touched it last and what's the record? Are you getting some of that now as well?
We are not seeing yet that this is an actual regulatory requirement, but regulators, we've certainly had a number of discussions where they're becoming very interested in what we're doing, especially if it's post-mortem after the fact of an accident and it's affecting worker safety. So one statistic I learned recently that was very surprising to me was that a worker performing rework is 70% more likely to be injured than a worker performing planned work. And there's about 1 million workplace injuries in construction each year that are associated with rework. So rework isn't just about the cost. It's not about, we want to save money, we want to save time. I was really shocked to learn just how much of a safety issue it is for human life, and making sure that workers can get home safely at the end of each day. Just get the job done right the first time. Don't go back to try to fix something that's already gone wrong.
Now, why would it be such a high incident rate on rework? Is it because the scaffolding wasn't in place, or safety issues aren't observed? What's behind that?
I think it's mostly because it's rushed. So when you look at accident failure, when you look at accidents in industries like aerospace, and this is before going into oil and gas, I was in the aerospace industry. It was always a cacophony of compounding errors that cause an accident. It usually isn't just one thing that goes wrong. Sure, that happens sometimes, one catastrophic failure, but it's usually one thing goes wrong, that causes someone to do something that's rushed, that was unexpected, another thing goes wrong, another thing goes wrong. Same thing with rework. Somebody already made a mistake, something happened, there was bad data, there was bad paperwork, whatever it was. Someone is then rushing to go back to fix it under very tight schedule pressure, and they're just that much more likely to have something go wrong that causes harm.
Now, tell me a bit about the environmental, social dimension to all of this. So as you know, the emphasis in energy and oil and gas in particular is on environmental factors, climate remediation challenges, methane reduction, CO2 capture and recording, and the like. How does like a digital twin of the workforce help offset or deal with some of these environmental concerns that we now face?
Yep. Again, it's about preventing accidents before they happen. There is a huge amount of focus in the industry on detecting leaks, whether with drones or infrared cameras, whatever it might be. And that's really important to do because we have to understand how much emissions are happening. But there's less emphasis from a technology perspective on preventing those leaks from happening in the first place, where we know they're very common. And that's where Cumulus comes in. Is our view is we know there's a lot of leaks, for instance, associated with improperly assembled bolted connections. About 20% of leaks, plus or minus, at a facility are typically associated with bolted connections. And if we can make sure that they're done right the first time, they'll have quite a significant impact on CO2 emissions. There was a study that came out, I think it was last year, that looked at a bunch of EPA data of fugitive emissions. Mm-hmm. And it found that if you prevent all of the leaks just from bolted joints, you could eliminate the same amount of CO2 equivalents as you would from removing 36 million cars, internal combustion cars, off the road. It's about 170,000 megatons of greenhouse gas emissions, methane and methane equivalents, just from leaks from bolted joints and bolted joint equipment. And you can find that on our website. I don't remember the exact link, but you could find the link to that study. And what we see with our system is we're typically after bolted joints are assembled, you see a 10 to 20% leak rate just from things didn't go properly. Our leak rates are typically around 0.1%. They still happen every once in a while, but it's about 100 times less common using our system than standard methods.
Yeah, just because you're able to catch it and detect the root cause, which was inadequate torquing or missed bolt tightening, what have you. You can see all that in advance.
Exactly. There's two big things that happen. One is the improper tightening of the bolts, which is what the sensors tell us. The other piece is just skipping steps in a process, not following the right process. And that's what our mobile app and the workflows do, is they make sure that the workers are actually following each step of the process. And if there is a problem, it's surfaced immediately before you start up the unit.
Well, that's an interesting angle, actually, in that the mobile device actually contains the correct process or workflow steps that the worker is supposed to do in a specific action, and can tell, well, whether they did it or not. You're supposed to use this tool for this task. The mobile did not detect the tool being moved. So therefore...
That's exactly right. It's project and process controls. It's making sure each step is followed. For instance, making sure whatever tool you're using is properly calibrated. That's a pretty common cause of issues, is using a non-calibrated tool. Well, our system will check for that and will say, is your tool within calibration? Does it have a proper calibration certificate? As just one example of something we check for to make sure the processes are being followed.
Yeah, it's akin to, again, back to my flight example, boarding a plane and not being sure if the pilot has actually had a recent test. Are they qualified to fly on this particular piece of equipment? We wouldn't accept that in virtually any other field, in air flight, for instance. And so Cumulus is trying to resolve, how do we fix that at the industrial worker level to bring value?
The same 4 nines of reliability that we take for granted when we board a commercial flight. Mm-hmm. How do we do that with the facilities that are in our neighborhoods and cities and operating, just as much risk of something going wrong? How do we make sure that doesn't happen?
Yeah. Where do you see this capability down the track? Like, where does this go? If a company is thinking about this, how far down the track could you see where you can say, hey, this is what a potential could look like here?
So, using your aviation example again, our vision for where this is going within a year or two is that our system will be an air traffic control for all the work that's happening on the site. So right now we're capturing all the workflows, all the work in real time, and our customers can view that in their dashboards. Mm. The next step is, well, let's actually use this data, one, predictively to understand what could happen in the future, but as importantly, to be able to actively make management decisions and affect those management decisions from your dashboard. So I want to reassign a work team to go from plant unit A to plant unit B, and I want to send those instructions out, that shows up on their mobile device, they go and do that work. And so to have much more, not just collecting data in receive mode, but sending out instructions in transmit mode.
Yeah, in two ways.
Yeah, we'll be there in a year, 18 months or so.
Yeah, that's really impressive. Another dimension to this is, I can imagine, is that once you have all of this data, your ability to then forecast better capital costs, startup costs, commissioning costs, inspections, all kinds of value gets released because we operate much of our project work with rules of thumb and guidance. And now what you're trying to do is really, this will unlock a whole bunch of these rules of thumb, which really don't make any sense in a more digital world.
How long does it really take to do something? Okay, now we understand it takes this many hours to complete this type of job.
Yeah.
And we can now plan for that appropriately. How many workers are really necessary for this for type A versus type B type of work activity?
Yeah.
All that information is, as you said, it's as much about not folklore, but just, custom and experience, and not backed by hard data today. Now we're providing that data for the first time.
Yeah, this is really impressive. Matt, thank you very much for coming on Energy Innovations today to describe this world of the digital twin of the worker. If people want to learn more about these the notions of smart tools, connected worker, digital twins of the workforce, where would they visit your site?
Visit our website at Cumulus DS, so for Cumulus Digital Systems, cumulusds.com. Also find us on LinkedIn, and we're very active there. They can also feel free to reach out directly to me.
Matt, thanks very much again for coming on the show today.
Thank you very much, Jeffrey. It was great to be here. Appreciate it.
This has been another episode of Energy Innovations, and I will return very soon with another episode. Please feel free to share this with your network so that others can find this content. And bye for now.
Thanks for joining our latest interview on Energy Innovations from Energy Now Media. Don't forget to hit that like button, subscribe, and share this video. You can contact us at info@energynow.com to book your appearance or to become a sponsor.